And welcome back.
Ah, yes. Welcome back. This is Module 4. We'll be talking about files and talking about process lifecycle management. We'll hit this for about an hour. Take a break for consuming food.
Yeah, about 30 minutes thereafter.
Yeah. And, all right, let's go ahead and start.
Okay. Let's talk about file namespaces.
All right, let's do that. Well, let's talk about why interacting with files is special inside Windows 8. So if you're writing a Windows Store application, one of the things you need to consider is that you're inside a sandbox and can't reach out to the hard drive without the user giving you permission to do that. Once they give you permission, though, then you can, but even then you have certain limitations. Limitations around file extensions, certain file extensions you can and can't, you have to identify those, as well as not every folder that you can go into. So let's talk about
the actual mechanics of interacting with files. You know, when we're coding in .NET, you know, we're pretty used to just being able to open a file and then interact with it straight away.
Yeah, yeah. Barry, just saying hi. Let me show you something. Let's jump over to my desk for a second. Let me show you something. So this is the architectural stack for Windows 8, and I think this is worth talking about because now that we're into files, there is a special thing. If I am writing an application in C#, and so that's right here, if I'm interacting with the file system, I go through WinRT, and WinRT has two core pieces. The first one we talked about, specifically when we were talking about sharing, is that it's the broker to make sure that I interact with things through a boundary that is a security level. So I can't talk directly, say, to the file system without WinRT allowing me to. So that's the first thing it does, is it works as a broker. But the second thing that it does is it makes me operate asynchronously. So I can interact with the file system first, because I have permission, and second, only asynchronously. And the reason it's asynchronous is because it goes back to the user is king. Mm-hmm. It goes back to performance is important. And asynchronous operations against things that take a long time give a better UI, give a better experience. It doesn't lock up the machine, doesn't lock up the UI. And so if I want to talk to the file system, I have to go through WinRT, and it causes it to be asynchronous. All right, so there is the first major change from the way a typical .NET developer might already know how to interact with the file system.
Absolutely, and it's kind of interesting. There was kind of this analysis, and I think it was any operation that takes more than 50 milliseconds.
That's right.
Was determined had to be an asynchronous operation, so as not to interrupt the user experience. And I think and
50 milliseconds is quick, and it ends up being basically every operation.
Well, what's really interesting is I think it's actually about 15% of the API footprint, but that API footprint is the primary footprint that you interact with when you're leveraging operating system services.
Right. In our previous day, we talked very little about asynchronous operations, but nonetheless, if you're a developer, C# developer in our case, right, and you don't know how to use the async keyword and the await keyword, you're going to want to, because interacting with WinRT is a commonly asynchronous task.
Absolutely, and so that requires you to understand a little bit about tasks, and perhaps task completion sources and so on and so forth, which we really unfortunately don't have the time in this particular session to be able to drill into. Do
you want me to go ahead and search it on MSDN now and start talking about it? I wish we could. I wish we could. All right.
Why don't you do that in a parallel task?
One of the things that changes from a .NET developer's perspective is that system.io.file is gone, right? And so the mind blows. But in reality, many of these namespaces have been brought down into WinRT so they can be shared across all of the languages.
Please show my slide.
Yeah, so they can be shared across all of the languages. And so you can see it's in windows.storage instead. Windows.storage then is available to C++ developers as well as JavaScript. And so we have the storage folder, right? Of course, that's the folder you would expect to do all the CRUD interactions that you would have, and storage file. Those are the core pieces. And I think it's important to recognize that those classes are the metadata around the folder, or the metadata around the file. You have that storage file in memory. You don't have the file in memory.
Yes. And that's really is a key difference, because you would open a file and you could have a file instance in the .NET framework.
Right. Now it does still lock the file, but only when you're interacting with it directly. And that's all going to be an asynchronous operation. You still have to close things.
Yes.
Yeah, you still have to be aware of the fact that you do lock files and resources. There is a storage.fileio. That's a place for some real quick kind of quickly writing to a file, quickly reading a file. It's nice, some of those helper methods that are in there as well as the pickers themselves. And of course, that is the way that you visually allow the user to go select, open or save a file, select a folder as well. And remember, you can use those third-party pickers to go, say, to SkyDrive or anywhere else.
Absolutely.
So if I do want to talk to the file system, the user has to be prompted. The way they're prompted is through the capabilities that I've indicated on the manifest. That's the first thing. But if I want to use them, once I have them, I can interact. Once the user's given me permission, then I can interact with them seamlessly. But there are two other places that files exist, and those are special only to my application. And the first one is the App Store. And so the app, let's not call it App Store, the App Storage, but it's the App Store. And it's where my application is installed to. And so I might ship some assets, like some images and some logos and things like that. They'll be deployed and installed into this location, and from that point forward, they're read-only, right? We don't want to manipulate that. That would allow me to change what my application actually does and then violate the contract, right? I don't want that. That's the reason it's read-only.
And the key thing is, you, even though you can access these things, you don't know expressly where that is on your file system.
That's right, and so that's why this syntax is neat. This ms-appx basically is saying wherever I'm installed. Yeah, it goes from there, / to the folder, and / to wherever your file is as well. So you can go just like that. That's what you can go to image tag source, and it'll interpret that for you. You can try and load up a storage file, and it'll interpret that for you as well. Then we have local storage, and that's more like isolated storage for .NET developers. It's a special set of folders that are created just for your application. They aren't shared anywhere else. You immediately have rights. You don't have to request permission to write to those. There are 3 subfolders in that area, and the first one is local storage. That's where you would put all of your files that you want, and maybe you have a database, maybe you have serialized data, maybe you have images they've created, whatever it is. Just be aware, if they ever uninstall your application, it's gone forever, right? Then you also have the temp folder, and the temp folder is the one that's recycled every time the user restarts their machine. And then that one that we like a lot, the roaming folder, that you can store things in, interact just like it's the local folder. And as long as you don't violate the size restriction, it will naturally, automatically roam to all the other devices you're installed on.
Perfect.
So the first is how to interact with isolated storage. So this is how to interact with your local store, and it's as easy as you would want. All you have to remember is the application data namespace. So windows.storage.application data. Inside application data, you can find the current local folder that has all the path information that you need. It returns the storage folder type to you, and from that point forward you have all of its methods to go and get a folder. So you can see there what's outlined. You can go get that local folder, and from there you can create a file if you want to, delete a file, anything you want, and you have full permission inside isolated storage.
So creation collision options are pretty interesting.
Yeah, well, you have to be careful. If you're gonna try and open a file that's not there, then you're gonna have to handle that some way. And if you're gonna try and write to a file that's not there, or write to a file that is already there and you're trying to create one, you can get all kinds of interesting collisions this allows you to handle it without a bunch of try-catches. However, some operations you just need to be aware will actually throw an exception if you're not careful. So again, it goes back to defensive coding as well, but these collisions help reduce the number of try-catches.
So an example of an expected exception scenario is that we may be used to using file exists.
Yeah, that is the painful one, and that's exactly right. I try and open a file that isn't there, and it'll raise an exception because it wasn't found.
Yeah.
And I can't say system.io.file.exists, which I was used to in .NET world, right?
Exactly.
So that's a try-catch.
It's part of that security. It's stopping you trying to probe to see what product or what files are already available in the file system. You have to explicitly request access to something, and then you have to deal with these collision scenarios.
Yeah, that's exactly right. I suppose you could also iterate through the files collection of a folder, but again, it just gets messy.
Yep, it's interesting. Things to be aware of.
Yeah, no doubt about it. All right, so then we have project folders, files. So remember, those are the assets that you have in what's deployed from the store. And so this is really nice. You might have a long list of states and countries and something else like that. All of these things you would want to actually push through and have it as part of the application. You might, again, install your application, then tell your application to go fetch the resources so that it installs more quickly. That's totally up to you, but if you ship them with your app, they go into project files. This is how you do it. Again, it's not the application data that you're going to the package. And so a package is inside an application model. .current.installed location. That returns the storage folder that has all the information where your app is stored. Again, you don't really care where your app is installed, just know that it is installed. This is the way you go straight to it. And then the interaction with it is identical.
One of the interesting things here is you can see that with the path, we're actually mixing and matching the system I/O namespace to be able to create path.combine, so there was no need to reinvent that wheel.
Yeah.
That once we have our path, subfolder paths and so on and so forth, we can manipulate paths in the same way.
Yeah, path.combine is just a convenience method to help you combine those. I could have done that with string.concat, I suppose, right? But this makes sure that it's never wrong. You know, too many slashes and they're all going the right way. It just does it all for you.
Yeah.
Some of those nice things. That's the thing. You know, when we look at WinRT, a lot of people are like, oh, okay, so now we don't have the .NET framework, but that is just not true.
Yes, you have the .NET framework. The areas of the .NET framework that are not applicable to your Windows Store application are suppressed.
Yes.
You can still try and hack around it and get to those things, but this is where when we touch on app certification down the line, this is where you have tools that tell you what things can't be used in a App Store app.
Like the interface, or like the namespaces that interact with the registry. You can't do that from a Windows Store app, and so those namespaces just aren't present in .NET for WinRT.
Absolutely.
Yeah, very nice. All right, so cool. That's interacting with project files. Then we have a file picker. That's a very common way of allowing the user to do it, right? You don't know which file they want. This is how you do it. It's very similar, actually, to the way you did it in .NET.
It is very, very similar.
Syntactically, you pass in the extensions, you filter right there that you want to show, and it opens up, and you just wait for them to respond and just be sure and handle if they don't pick a file at all.
One of the key things I think that is different here is the inability to specify wildcards and to arbitrarily search for any extension. You know, you have to declaratively express the explicit set of extensions that you want to use.
You're absolutely right, and you can see there we're saying .text is what we want to find. You could not say .star.
Yeah.
Yeah, that's right. And again, that's just that's the way it's designed.
Yep.
Okay. Now you could also interact with. So this is interacting with the user's document library. I think that's important to say. You can't use I mean, yeah, you could, but it'd be crazy to use a picker to go through your local files in your local folder, right? That is really meant to be done programmatically. This is when you want to reach out to their libraries, their photos library, document library, whatever it is they've got.
Or also one of the registered extensions.
One of the registered extensions going out to their SkyDrive or whatever, including going out to their home group, you know, because Windows can create a home group very easily. If you want to access those, that's where a picker comes in. And it's nice because a picker is less constrained. You don't have to ask for permission because the picker is the request for permission.
Exactly.
And so I don't have to say, can I please use a picker? A picker is just a picker. There is no other way to access those libraries, but one other thing is they can't, if you want to access the library itself, you ask for permission only if you don't use a picker. So that's the next slide. That is us not using a picker. So without a picker, can I still go out to the document library? No, you cannot. That's probably the first thing to say until the user gives you permission to get there. So I can install your application and know that you're not going to be rummaging around through my document library until I give you permission to do it and I know that you're a trustworthy app.
And you have to declare that intent within your application capabilities.
That's right. So the appx manifest file, that's that XML file we talked about before that ships with every app. There's a little snip of a screenshot there in the bottom corner where documents library is now checked. From that point forward, when the user installs it, they can see all of the capabilities that IS is going to use, and if they think one is suspicious, they just don't install your app.
Sounds good.
Yeah, so without a picker is very similar. You can go to known folders, and then so windows.storage.known folders, and you can go get the documents library. And that list is the list you would expect. You can also get the photos library. You can also get the video library, and you can go on from there. It's really nice.
Sounds good.
Yeah, so you still have the seamless way of programmatically interacting with the user's files once they give you permission. Not every time you ask, by the way. It's just at the beginning. Yeah. Okay.
Once that permission's been granted, we talked about the settings charm. So a user does have the ability to open up the settings charm to be able to view the permissions that they've granted in an application and revoke it down the line. So again, you can't always make the assumption that just because you have permission now that you have permission in the future. So again, you've got to code defensively.
Darren, do you consider yourself sort of a small vehicle mechanic?
No.
No? Well, this next section is going to be hard then for you because have you ever seen the movie Tron?
No.
Oh, really? That's crazy. And you're in this profession? So, the light cycle in Tron is an excellent device, and so being able to, take care of those is important.
You think this is a bit too much foreshadowing?
Maybe so, yeah.
I think you can.
All right. It's not light cycle management. It is life cycle management, and that was deafening.
That's
what you do when you work late.
Exactly.
That's exactly right.
It seemed a lot funnier.
So much more. Nonetheless, let's go back to the architecture slide. This is really where it matters, right? And so your application is now running inside the Windows runtime. That's Windows RT. Process lifecycle management means WinRT will impose a new lifecycle that desktop developers especially are not used to. And so let's talk about what those are. Probably an analogy is the best way to go. This would be a metaphor instead, though. It's hard to keep those straight.
Exactly.
And so metaphorically speaking, if your application was like a card deck,
it's almost as if we prepared this.
It's crazy. Then that card deck, it's a stack of cards. Just like all the applications running on a user's machine are like a stack of cards. Whatever is on top and visible is getting its threads scheduled to the kernel. That's important. All of the rest are not. It doesn't mean that they are in some special low power state. It means that they are absolutely in a coma. They are not doing anything.
Completely quiesced.
They are completely quiesced. But that's absolutely true, and that's important for a developer to think, because while you're on top and you have all the resources that you can reach for, you can just go to town. But
relatively speaking,
you're not always going to be on top, right? Sometimes the user is running your application and they suddenly want to change the applications on top to check their mail or whatever. And they swipe over, a new application comes on top. You are moved down in the back stack, you're no longer on top, and now you are fully suspended. So let's talk about how that kind of life cycle goes through. So we are in a state, so you have 3 possible states. That's going to be running, or suspended, or terminated. And there are these transitions between the two. So let's start with the first one. All right, so we're running. And when your application runs, then it is everything you expect, right? No tricks here, it's just running for you.
Yep, you're running in the sandbox.
That's right. The user loves your application, everything is fine, and they decide that they need to go check their email. A transition state begins of suspending. The nice thing is, developers writing their application, suspending isn't instantaneous. So you are allowed a small amount of time to handle whatever it is you need for suspending, and we'll talk about the strategies for that. But then you end up suspended, and suspended literally is suspended. There is nothing else going on.
So what if I have a timer, or I've got a network transfer going on? What happens?
So if you have a network, all of this kind of depends on how you've implemented it. But the reality is, if you do have a timer in memory and suddenly you're suspended, so is your timer, right? Everything literally is suspended. The kernel's no longer scheduling processor operations. Nothing is going on. It really is. The nice thing is, there's fast app switching inside Windows 8, which means all of your application RAM, or all of your application processing, is moved into RAM, right, for you. You don't have to tell it to do that. It's done automatically and very quickly. And if the user is checking their email, switches now back to your application, it's immediately brought back, and you're immediately back where you started, right? You don't have to think, how can I do this fast switching? It does it for you automatically. It's very nice. Okay, so that's the first, but that's assuming the happy path, right? Yeah. And so this is the happy path. You're suspended, and you go into the suspended state, and then you are resuming, and you go back into running. That's a nice little cycle, but it's not a guaranteed return path. And so hit it one more time, and so this is something else that could happen. So again, picture the deck of cards. The deck of cards has 2, 3, 4 cards on it, fine. Now it has 5, now it has 10, now it has 20, now it has 40, now it has 50, and the operating system says, whoa, my memory consumption is getting a little high. The topmost app that has priority might have some memory constraints as a result. We're going to take some of the cards out of the deck, and we're going to make some room because of it. And it's a pretty neat, I don't know if you've ever seen the demo where you can actually consume all the memory and all of the Windows Store apps just go vap, right? They're just totally taken away. And again, it's the user, it's the operating system taking care of the user, saying, we're going to get rid of all the stuff that could constrain performance and could impact your user experience. This is important for a developer.
So, as a developer, though, what event do I get when I'm going to be terminated?
Well, you get, exactly. You get there is no event, right? That
White
is the
noise.
problem. Yeah, nothing happens. You are once you're blue there, you're already suspended, right? You are already not running, and from not running to terminated, there's no difference, right? I mean, it's just now you're out of memory as well. The only thing that happens between those two states is a flag is set on your application that so that the next time it runs, you know that it was terminated. That's the only thing you really get out of it. And so that means when I am going from running to suspended, I need to really expect to be going to terminated.
Okay, so this is that defensive coding that we've been talking about throughout, that we need to consider these scenarios. We can't react to them because, as you say, when we're suspended, we have no operating cycles to respond to any termination event. Therefore, we have to always assume that when we're being suspended, we could be terminated, and we have to do everything we need to prepare the application to resume or to be launched again.
Yeah, no, you're right.
From that state.
Yeah, that's exactly right. You have to assume the worst. In fact, it would have almost been better that so there is an event. Suspending is the only event that you get.
Exactly.
And it's a 5-second delay that allows you to have 5 seconds and not 5.1. 5 seconds exactly, so that you can take the data that you have in memory and quickly save it down. 5 seconds is not always enough, right? So if you've waited and saved all of this operation that you need to do to take place in these 5 seconds, you may actually go over your 5 seconds. Operating system will not be lenient, and you will be terminated in the middle of one of your operations.
With extreme prejudice.
With extreme prejudice, exactly. So I think you should consider the suspending event. I wish it was renamed to terminating, honestly.
Or candidate for termination.
Yeah.
You have been slotted as a potential candidate for termination. Prepare.
Right. I've gotten that notice.
Yeah.
Okay, great.
Is that envelope up there?
Yeah, exactly. Right after this course. That's convenient. All right. The next slide talks about another consideration around lifecycle, and that is the ability to do things even when your application is not running. So you can see that when you're suspended, you're just not running. But background tasks are always running. And so background tasks are based on a lot of different things, but what they really do is allow the developer to be able to do something even if your app isn't running. And so,
are they always running?
Well, they are not always. I skipped slides in my brain and I didn't say. No, they are not always running. Well, no, they are absolutely not always running. In your mind, you may, not you, but some sucker might think that it's a Windows service, right? It's running in the background. You can do it whenever you need to. But the reality is, you are constrained to certain timing intervals, maybe different events. In fact, go to the next one and we'll talk about it. This would be the triggers that you have. So you might have on the left there a list of all the triggers that may cause.
Remember these, we will be asking questions later.
Yeah, that's right. What was the seventh one?
Yeah, exactly.
The triggers on the left, though, indicate the things that could cause your background task to execute. So you could respond to events in the system, and the operating system is basically monitoring for them, and you latch onto those as you create the background task. The first one is the time trigger, and it's probably the one users or developers think of immediately, right? Well, when could I do it? Well, I want something to run every 10 seconds. Well, there's a trick already, right? Because the time trigger is limited to 15 seconds. So if your application needs to run more frequently than every 15 seconds, this is not the right approach, because as soon as you indicate that it's 14 seconds or something below that, that is a one-time trigger that only fires the first time. So the time trigger is a 15 seconds. So now you might be thinking, well, my application needs to run more frequently than that. Well, if it does, the reality is it can't. Right? Yeah. That's the best way to think of it, right? And you may want it to, but now we're inside the store app mentality, and we're trying to understand how can we solve the same problems given some of the new paradigms that we get to deal with. Now, conditions on the right are special too, because background tasks only have a certain number of CPU cycles to run, right? So if I have a background task, I have 1 CPU second to execute the entire thing. That 1 CPU second threshold has to last me for 2 hours. So inside a 2-hour window, I only have 1 CPU second. If I use it up in the first minute, I have to wait 2 hours or 1 hour and 59 minutes before I get a refresh of that threshold, which is fine. That's the way it ends up. But now I have to think even more smart, right? How can I not burn CPU cycles?
Well, exactly. You don't want to waste that precious time saying, is the internet available?
Right. Or is the user there, or whatever. And so the conditions are very valuable because of that.
Because the system does that for you and will only launch you if the conditions that you've asked for exist.
Right. I think it's worth saying there is one special thing. That is, on your start screen, there is room for 7. In fact, let me show my screen for a second. I'll show you something interesting. If I were going to the settings and going to the lock screen here, I have room for 7 apps that I can choose, and based on the apps that I have installed. I'm a developer. I write an application. I make it so that I can be on the lock screen. And why would I want to be on the lock screen? Because now instead of 1 CPU second every 2 hours, I have 2 CPU seconds every 15 minutes, and that's quite a bit more. Right? It really is quite a bit more, and allows me to be more important to the user, right? Again, there's only room for 7, and nothing can stop the user from coming in and taking one away, right? So my application could be better if it was on the lock screen, but it certainly can't require the lock screen because, again, the user's in control, not me. All right, great. So that's background tasks.
Okay. Now let's talk about activating Windows Store apps.
Okay.
I saw there were some questions about Store app activations and so on and so forth.
Good. I'm glad we're going to be covering it again. In fact, I know we're going to hit protocol activation here in a second, which is a really great one. There are 2 ways that an app starts. All right. So the first one is launched, and the second one is activated. And it's important to understand the difference between the two. What is launched, Darren?
It's effectively a user clicking on the tile for an application and starting it.
That's right. And I think the important takeaway there is starting it. It wasn't running before, right? And so contrast that with activation.
So activation may be another application is trying to reach in and launch something not through a direct user action. You could also be responding to things like notifications and so on and so forth. That it's bringing back the application from a certain state.
Yeah. Yeah, that's exactly right. And so launched basically says your application is not running, and now we just launched it. Congratulations. The other one, the activation says launch your app. Oh, it's already launched. Just
bring it to the front.
Yeah, just bring it to the front. And so there's a lot of ways your app can be activated. What's nice about activation is that it will cause it to be launched if it isn't launched, but it'll just activate it if it is. And so there's a lot of ways you can do it. The first would be the tiles. We talked about those earlier, how those live tiles are a way of interacting and showing data from your system. There's also secondary tiles, which are a way of deep linking into your application. That's kind of a Silverlight term there. But basically the ability to go deep into your application, skipping the menus, going directly to a details page or something like that. And then we also have toast notification, which work like tiles.
Swiping it in from the left-hand side?
Swiping it in from the left-hand side, right? That's like Alt-Tab style.
That's shuffling your deck.
Shuffling through the deck, and it gets brought back to the front. That's right. You could share to it. That would cause it to be invoked. If it wasn't running and you try and share to it, the operating system will automatically activate it for you. Search is the same way. And then the 2 really interesting ones beyond the most obvious are file and protocol activation. And file and protocol activation are, well, let's talk about them explicitly. File activation, we talked about PDFs launch the Adobe Reader. That's the idea. You declare that inside the manifest. And here's what's really cool. When more than one item is specified for a file activation, so let's say it's .xyz, maybe nothing is specified for it. So you get this dialog that's on the right there, and it says, which one do you want to use? Something that's already, this is PNG. So which one that's already installed, and you get to pick between the 4, or you can go into the store and find something that more options will allow you to go even deeper. And so that's really cool because it's a way of discovering applications that are in the store that you may not have found otherwise that have that same type of activation. It's a very powerful way of doing it.
And it's a key thing to consider when you're designing your application because you want to get as many people using your application as possible. So employing these capabilities and making sure you expose them out as available gives you all these different channels for users to find your application and install them.
So I don't want to respond to PDF. I want to respond to EXE.
EXE. That sounds scary.
it's not allowed. Right?
Exactly.
In fact, there's a long list of extensions you just can't do because, again, it goes back to the user. You don't want to confuse the user, and now all of a sudden something they thought was a program run. Sure, I mean, crazy.
Yeah.
So there's a list of things that constrain us there. And just like running an application, I can type notepad.exe, space, and then I can pass in an argument, right? And it knows to load that file. You can do that same thing with file activation. So they can say whatever your file dot whatever your extension space, and they can start passing in command arguments that allow you to do even more and interact with it even better. So I could launch that from another application. The user could pass commands that way directly into your app. Very powerful, and it's what we've always been able to do this in .NET. I think an important part is we can do it here as well, and it is a way of activating, not just loading, right? So, when I double-click a file, it launches another instance of Word, right, or something like that, right? I can control that now, so there's a single instance, and it reactivates.
Yeah, so one of the interesting things about that, though, is architecturally, you need to really consider that in your applications. If you have all of these different ways that the application can be activated, it may be running, it may have a memory state, but in suspension. Then you activate it through one of these different protocols or whatever. Your application gets brought back to the forefront with its current state and then has to respond to events to move and do what it needs to do. So you also need to consider, okay, what do I do with my current state at this point in time in responding to it?
Yeah.
So again, this is one of those things you've got to think about and plan through the various life cycles that your application is going to go.
And how do you know what's actually going on? It's because it's in the app.xaml. And so app.xaml has a set of events that will be raised. The first one, I guess this one is an event. It's an override. It's a method, and on launched, and so you know that it's been launched, right? And you also have on activated, so you know it's been activated with a argument to that method that tells you what the type of activation is. So you know if it's from a file, you know if it's from a protocol, because you have different types of interaction if it's from a protocol or a file. Let's talk about protocols for a second, because protocols I love. If I say HTTP:, it tells the operating system to launch a browser. If I say mail to:, it tells the operating system to launch my mail client. If I say Darren:, it tells the operating system to launch your Windows 8 app because you
and not to mess with my colon.
What's with Darren's colon? And so you can have your own custom protocol that way, and it allows you to call it from other applications. You can call it from the run dialog. You can call it from a web page, which is pretty awesome. I mean, really it is. And it launches your application directly. Just like in file activation, you can use commands. In this case, it'd be in the format of a URL. And a URL can have anything. It's just string, right? And so one of the things you can put in a URL, as an example, would be a minified JSON, right? You could put that together, so you could pass an entire class if you really needed to. And so there's a lot of power.
And one of the key things as well is, we're talking about expanding the reach of getting your application out there. You can create your own websites, obviously, to promote your applications. And as Jerry says, if you've got that protocol activation embedded in that web page, somebody can click straight on it. If your application's installed, it's going to bring it up. If it's not installed, it's going to take them to the store.
That's right. Take it to the store, filter the store of all the apps that only have that protocol.
Yeah.
Which is really, really neat. I tell you, as an aside, all the apps that I put into the store all have a recurring protocol. They're all, even if they aren't relevant, right? And it allows me to find my apps really, really, really quickly. And it's a neat thing to be able to do. And you just try to activate it on your machine. You say, you'd say window run, right? You say your protocol : and then it'll pop up and say, run this one or go to the store. I go to the store, see them all there. It's really nice.
Yep.
It's really, really nice. Okay, anyway, that's protocol activation. These custom protocols are nice. Just like file extensions, there is a limited set that you can't use, right? There's some reserved terms.
Yep.
Yeah, absolutely. All right, now that we know that there are some constraints, I run inside a sandbox, and I am like a deck of cards, and I do have these events that I have to handle for state transitions, and I do have the difference between launched and activated. I need a strategy, and so some of the guidelines or strategies around state management include if the user is coming into your application, you should, this is going to vary based on apps, right? It's not always the same, but generally speaking, you should resume where the user left off. They shouldn't know that you were terminated.
And that's precisely it. I mean, really, it's around satisfying user expectations. Just because they flipped across and looked at mail doesn't mean when they come back to the wonderful tweet that they were writing, that tweet should have disappeared. They expect it to be exactly as they left it.
That's exactly right. Now, there is a case where a long time has passed. They were writing a birthday card 2 years ago, and they come back into your application. Enough time has elapsed where it does make sense to start fresh.
Yes.
Right. I mean, of course, 2 years is a long time, but really, sometimes a few hours is a long time.
If it's exactly 2 years, it's perfect. Still a birthday.
Congratulations! Yeah, that's exactly right. So we talked about saving data, and there are two types of data. There is the state data, and there's the application data. And the application data is whatever the user might be doing, say like the tweet in your example. And then there's the state data. Where are they located in the navigation stack? Where are they scrolled to? Things like that. And those two things both need to be saved if you want to restore it back to where it was before.
Exactly,
and so,
because we have to assume that we're going to be terminated.
You have to assume that suspend means terminated. That's exactly right. But with only 5 seconds, Darren, sometimes that's too much data to save. What's a strategy to survive that?
You need to think about these things in an incremental way. As you move through the application, as you create little snippets of state, save them out. Assume that the worst is going to happen, that you're going to get slammed down, you get suspended, you run out of resources, the OS kills you. If you haven't made sure you've done all of this data as you go, if you want to have, somebody's writing a long document, say you're creating a text editor or something along those lines, put something in there that periodically is saving that state as they go. Don't rely upon them hitting a save button. Flip it around. Their expectation is their content will be there when they return back to that application, especially in these fast switch scenarios.
Yeah, so kind of how Office does autosave. I mean, if it is restoring for me, I may lose the last sentence I wrote, but it's trying at least, right?
Exactly.
You can do as much as you can. If the user's navigating from page to page to page, save as they're doing that navigation. Basically, don't queue it all up for the suspending method or the suspending event. You're going to be in a heap of trouble.
Especially if you're using external services for your storage. The user might go into a suspension, and for whatever reason, that external resource isn't available right now. Your network connectivity has dropped, or whatever. The external service could just be down. You've waited to that point. You've got no time at all to implement an alternate strategy or whatever. Think defensively.
And there is no rescue. That's the important part, right? It's just gone.
You can't say, wait!
Yeah, you can't do it. So there are some helpers out there that the user can leverage, or a developer can leverage, and one of them is the suspension manager. You can get the suspension manager when let's see, you get it from some of the Visual Studio templates that come out.
Absolutely. So, if you select any template, I think other than the blank Windows Store app, you get these in the common folder.
Even if you select the blank, as soon as you add one of the types,
one of the layout pages,
then
it's going to insert all of the dependencies that is necessary.
Now, I use this occasionally in my projects too, and I tend to just pull it into my project, right? Because it adds quite a few files. I don't always want all of them.
Absolutely. And so, that's typically a good pattern. Is I think all of us as developers, we build up our own sort of external utilities, like assemblies. And so, I tend to do pretty much the same thing.
We just wire stuff together anymore. Nobody codes from scratch anymore. So look at the syntax. I mean, there are 3 main things that you get. The first thing is just the setup. Register frame. Again, we were talking about navigation, how it's a frame with pages inside. This is how you tell it to monitor that. Then you save and you restore. So as you are suspending, you save. Once you're reactivated, you restore. And so the idea is it goes ahead and puts everything serialized into a file for you, brings it back. So the user is not only do they get not only do they get to come back to the app the way they saw it, but it's actually navigated into it deeply. If they're 2 pages, 3 pages in, they're back. Still goes back to where they would expect it, and it's a consistent experience. Now, data is a different story. If I'm going to store the data that the user's interacting with, the suspension manager doesn't know anything about that. So I'm still responsible for doing that extra step. This is really about managing the user's location and the navigation inside your app.
Absolutely.
It's really nice, though. I mean, it really is handy.
Yeah, if we flip back to this slide for a second, we've got, there's an interesting thing that we should point out on the suspending, is by default, if you go execute through on suspending, as soon as you return out of that override, you are finished. The application will be suspended. If you look at the suspension manager save async, it's async. There's an await on there.
Yeah.
By default, as soon as you hit await,
it will release the method.
It will release the method. And as far as the infrastructure is concerned, on suspending is complete, goodbye.
Yeah.
That would be disappointing because you've just started to do your suspending operation. You haven't finished it.
No, that's exactly right. Now, how can we solve it? Because we still want to do these things asynchronous. Even if we don't want to, sometimes we have to. We're writing to a file.
Exactly. And so they've introduced this deferral mechanism, which in effect you can turn around and say, hey, I'm starting to save, so I wish to grab this deferral object, and I will flag you when deferral is complete.
Yeah, it's kind of like putting a pin in it.
Exactly. But, and here is the big but. Boom, boom.
Ooh.
Oh, dangerous.
Can we do this on TV?
Here is the big but. Is it does not change the fundamental promise that you will be terminated if you exceed the available time.
Oh, so deferral doesn't say defer my time so I have 6 seconds instead of 5.
It just says don't shut down immediately.
Yeah. Hang on, doing an asynchronous operation.
Give me up to 5 seconds, and I know you're going to kill me if I go longer than 5 seconds. The flip side of it is it does allow you to manage and turn around and say, okay, it's only taken me 1.5 seconds to save. I've now released my deferral, and the operating system is free to suspend you.
It sort of acts as if it's done synchronously now instead of asynchronously. So since we're talking about helpers, we know that we have the suspension manager, but we also have the layout aware page. Layout aware page comes in very frequently, right? You get it the same way. It's in those templates. And layout aware page does what we do manually all the time, and so it's really handy to have. The first thing it does is handle orientation changes. That's probably its number one thing to me, right? When the user snaps, when the user rotates, when the user goes to portrait mode or whatever, those visual states are set automatically for me from that point forward. And so then all I have to do is manipulate what happens inside those visual states. I don't have to listen for the events because I know the base page now sets all those for me.
Yep. So that's really what the name suggests, but buried in there is a couple of methods that override or provide the ability to load and save state. And they're leveraging dictionaries that are actually within the suspension manager to allow us to write out a state dictionary.
That's right. And so it's perfect. Load state, save state. Those are basically the times when it's about to happen. It's listening to all kinds of things in order to get it just right. And what's great is it's the right time to do it. And so it gives you a couple seconds to do it, whatever. Oh, no, actually, it's not timed. It just gives you the time to do it. And that way you don't have to say, am I navigating from, to, it's all right there. Just
allows you to deal with your
state.
Incremental activities.
Yeah.
The key thing to bear in mind with this dictionary and with the state management of the suspension manager
and the settings dictionary, since I know where you're going,
exactly, is it looks like object, and it looks like you can write anything there. And yes, indeed, you can write anything in there. However, when the suspension manager is actually processing its saved state, if the object is not a simple type,
base type, that's right,
then it will throw us a serialization exception just when you can do absolutely nothing about it, which is just before you're going to get suspended.
It's a frustrating thing, but it's just the way it is.
Yeah,
if you know
you have to embrace the constraints.
It doesn't mean you can't serialize it yourself. It doesn't mean you can't save it out to a file serialized on your own. It doesn't mean you can't send it off to a service and let it handle all this state.
You just need to plan
If you
it.
want to use these dictionaries, just know object doesn't mean custom type that can be serialized.
Yeah. As Jerry said, there needs to be a generic where on there that says where not custom type.
Yeah. It's especially important when we're talking about the parameters being passed to navigated to page, and we'll talk about that when we talk about navigation strategy.
And also, just think about it in terms of you shouldn't be saving these huge objects unless you absolutely have to. You'd be much better off putting key information to go and be able to find that object and bring it back in.
Yeah, that's exactly right.
So,
doesn't mean you can't have local data. It just means store it in the right place.
Okay.
Yeah, absolutely. All right, so let me pull up Visual Studio and show you something.
Sounds good. Hopefully it's code.
Yeah. All right. So let me start one from scratch here. I'll open up a new project, and so I want to show off. I want to attach to the suspending event, so you can see kind of how to do it.
So a simple example of the life cycle.
Yeah, it's just as simple as it comes. Now, I won't use the suspension manager.
Oh, you're going to show off. You're going to create your own, huh?
Yeah, I like to code, and so here we go. I'll do it all. There's a lot of C# here, to be honest. This isn't just the XAML demonstration. Let me.
This is the C# in the title, by the way, guys.
Yeah, right here. We're hitting it right now, baby.
Yeah. Watch it. Oh, it's gone.
That's right. Where's Barry? let's see, the list box.
Anybody seen Barry?
All right, I'm going to add a list box. That's where I was headed. So I've got a list box here. I'll give it a nice size so we can see whatever it is I type and make it just a hair bigger so it's nice big. All right, so if I were to run this application, let me show you something. Have you ever seen this before?
I've seen something.
All right, so first of all, this would not probably qualify as an excellent...
I'm not sure the user experience warrants the effort
I have
to publish
taken away
this.
the Chrome, right? I mean, doing more with less.
Exactly.
All right.
I'm sure you're used to that.
I'm going to change, Darren, this is you right here.
Uh-huh.
Right? Very nice. And I go off and I do something, and now I go back to Visual Studio. I'm going to add a menu bar that's not there, right? Everybody's going to have to add this if they want to do it. And it's right here, debug location.
Why is it called debug location?
Yeah, so I'm going to go ahead and select it, and then here it pops up, and, debug location gives me this little button right here. And the drop-down is probably more important than the button itself because it allows me to simulate suspend, simulate resume, but more importantly, simulate suspend and shutdown, right? So this is getting removed from that stack.
So if you hit stop in Visual Studio regular debugging, does the terminate event or anything fire?
It does not. Right?
Okay, so that's why we need this.
Yeah, because we want to be able to test it. If I hit stop up here, it doesn't fire. You're 100% correct. It just kills it, frankly.
Yeah.
Stop is pretty brutal.
Yeah.
Anyway, so I'll go this drop down here and I'll say suspend and shut down. And when I do, the app is no longer running, right? I can't go back to, that's not the same app. I can't go back to the app because it's not running. It's gone out of memory. Now when I run it again, remember I typed Darren in the text box? Mm-hmm. Now when I run it again, resume, well, it will resume. And I'll go ahead and run it here. It's like taking forever because it's so complicated. And it has the default value.
What's my name?
Darren, you've been lost into the ether. So I want to make it so that when suspend occurs, I store whatever that is, right? It's easy to do. This is really easy. So let's, child's play is what it is. I'm going to give this a quick name of, what would you like to call it?
Darren.
No. Text box 1.
Okay.
Right, that is original.
Your imagination is stunning.
It is awesome. All right, great. All right, so here, this is the code behind. This is what I like to do to the code behind. I'd like to delete all of the comments. All right, here we are. So this is what the code behind does. All it does is initialize all the XAML, and the rest is up to me. So I will have loaded, and here in loaded is where I can bring back Darren, or whatever it was the user typed into the text box. But there's one other event I want, and it's in the application itself. Remember, it was
so how do we get the app?
Well, the app's easy enough to get to. It's a static reference, which makes it really easy. App.current is how I get to it. Now I'm there. Yeah. Wait, really? And
yeah,
then
it's awesome.
Suspending is the event that I want, and so I'll just do a quick attach to that. So here I'm handling suspending. That's when I save my value. And here's loading. That's when I would load my value or read it from wherever I want to.
Okay.
Let's put it in settings first, right? Let's see how that goes.
So we're going to make this application wide?
We will make this application wide. Yes, that's right. Settings will be application wide. Let's roam it.
Oh,
show how roaming is implemented as well. All right, so we know that roaming and everything else is an application data namespace. There it is. Dot current, so that's my current application data. Dot roaming settings, because that's just a simple dictionary. And then I can say values. Boy, it's wide, isn't it? I'm going to see if I can get this out of the way. And then I'll give it a name. I'll say my data. Make sure I don't clash with something. I actually like to put the namespace of the page that's saving it when I really do it like this.
Yeah.
And equals, let's see, wait, suspending. Yeah, I'm saving. I say text box 1 dot text.
Oh.
Boy, I messed that one up. Text block 1.
It's box.
Yeah, that's it. Text box
1. See, if you'd put Darren, that would have been easy, wouldn't it?
Yeah, I wouldn't have gotten it wrong.
Exactly.
You just like the idea of IntelliSense with your name. All right, text. All right, there we go. Basically, all I'm saying is inside this dictionary, which is located in the roaming settings, which means it'll push you over, right? By the way, roaming works even in the debugger. So, I mean, it's immediately effective. And if you want to, you can't cause roaming, right?
Yep.
It's up to the operating system. But if you want to cause it, you can. How about that for contradictory? You really can. All you have to do is lock and then unlock, and that lock operation causes roaming to invoke. Okay, so here we are. I'm just saving it in there.
Don't try that at home, kids.
You can try it at home. It's okay. And then, let's see. And then I want to load it back in. So the way I would load it back in, look, I'll just copy this, and do it backwards. Right? I'll read it, convert it to a string so I can write it to the text box. Now this is going to be a problem, right? Because right now there is no value of my data, and so I need to check for that and then handle whether or not it's null. And so there's a lot of ways you should, or just wrap it in a try-catch and do it anyway, right? It's tempting to do it both ways. I will do it the right way. Are you ready? I hate doing things the right way. All right, so I'll say...
It's unnatural. I expect to see errors.
If values contains key, right? And we know that the key is my data. Oop. There we are. There we are. Actually, let's do it backwards because then I don't have to have a bunch of things wrapped together. So if it doesn't contain the key, return. So I don't.
Or just put a value not found.
Oh, I could say whatever the default is.
Yeah.
That's a great idea, by the way. Now I got to wrap it all.
Sorry, man.
Good job. Yeah, that's it. Perfect. Otherwise, if it is there, now I want to go get it. That's right. So I'll go ahead and just get it directly from it. Oops. I guess it's below instead of above.
Yeah, just copy that.
So I know that it's there, so I'm not going to get an error of it's not found, but it could actually be null, right? If I want to handle that. And so I'll say, so I know that the value is moved into it. Its type right now is going to be object. And I'll just say text equals value if value does not equal null. All right, quick little check. Then I'll say value.
That's string null or empty.
I could do string null as well. Yeah, I totally could. Or string.empty and things. Yeah, exactly. But I'll take it no matter what. That'll allow the user to type in blank and still work. All right, so if we look at what we did, this is the suspending event, which we attached from the current application. And all we do is write it to a quick dictionary. We could put that anywhere. I could write it to a file as well if I wanted to, send it up to wherever I wanted. And then on the loaded page, all I do is go see if it's there. If it's not, there's a default value. If it is, I'll read it and jam it in there. That should bring you back from the dead.
Are we going to try this first time?
Dun, dun, dun. Well, I mean, it's only you. Oh, look, the default value showed up. So far, so good.
Yeah.
We know that there's nothing inside that dictionary, so default is what we should have seen. The value is there somewhere.
Yes.
Like,
there it is.
There it is.
Right.
Got it. All right, good. So let me delete default value. This time I'll put in Darren. All right. And remember, I don't want to just terminate it. I want to go ahead and do this, simulate the entire suspending event. So here I'll start to suspend. Now, before I do, I'm going to put a breakpoint here so you can see that it's really happening. It's pretty fun. All right, so I'll say suspend. Boom. See that? Did you see that?
I did.
I mean,
it's in color. It must be true.
All right, so now it'll save it for me. Now we know that it's in there. And then the next operation is the terminate, and now it's out of memory. Now, I could debug that, step through it, and take more than 5 seconds. It's not a true suspension that's going on. It's simulating the suspension.
Simulating it gives you the opportunity to exercise your logic, to understand what's going on.
That's right. And so now we run it again, and lo and behold, Darren is back. Oh. Yeah, that's exactly right. Okay, so this is how easy it really can be. Once you understand the constraint, you can deal with it very easily.
Exactly. Now, obviously, in a real application, you may have more complex state that you need to deal with. And so you want to make sure you do test some timings. Make sure you put representative information in there. Try and simulate the environments in which you will be saving to make sure you don't violate the limitations that are in place. It's very, very key, especially for non-trivial applications.
There is nothing in the simulator to simulate poor performance. It's really up to you to find a bad machine, to really try it on. And can I save this in 5 seconds? Odds are you can. Honestly, things just go quick. But there is a possibility that it can't, and you don't want to wreck your machine or wreck your application or get a bad review in the store. I mean, you don't want any of those things. In the end, the operating system is for the user, but so are we, right? Because now we're aligned with the operating system and the user experience. So that is the process lifecycle management, right? That is what developers get to think about, that deck of cards when they're on top, but when they go below, they could be completely terminated.
Absolutely. So just as a recap of the module, we touched on file handling and we showed the different scenarios and where you could interact, the namespaces where they're stored, and also kind of mentioned the challenges around async and making sure that we covered those.
Yeah.
and then we touched on the process light cycle and the management thereof.
Yeah, exactly, and that's using that suspending and thinking about it as terminating. Or what was the one you said? Candidate for termination.
Indeed.
No doubt.
So we're now going to take a 30-minute break for lunch.
30 minutes.
3-0, and we'll see you guys back soon.
See ya.